Hey, everybody. Okay, so today is our SimVascular workshop. So hopefully everyone has SimVascular installed, and so if you can open that up and just be on kind of the homepage for that, and then we'll pick it up from there once the class starts. Right. Oh, I don't want this yet. All right, so if you get your SimVascular to look like this, then we'll pick it up from here once the class starts. You have to download the sample. And so there's a demo project that's provided by the SimVascular website. So if you can download that, that's going to be our starting point. Yeah. So did you see at the end of the video I showed you how to download the demo project? Yep. Mm-hmm. Yep. Yeah. So just this is you know, a regular lecture. So I'm recording it and I'll be posting it afterwards too. Oh, dang. Sounds like a rough day. Okay, it's 5:30, so let's go ahead and get started today. All right, so how's everyone doing today?
Pretty good.
Good. Excited for SimVascular?
Yes, I am. I'm really looking forward to it.
That's good. That's good. All right, so today is today is it is an exciting day. So we're going to be using SimVascular today. Okay, and so hopefully everyone has downloaded the software and has downloaded the example project too, or the demo project, I should say. Okay. And so, you know, I want today to kind of be interactive. So, you know, I'm going to be working through the demo, you know, on my screen, but I think for you guys to kind of get the most out of it, I think it would help if you guys are doing it as well, because it's one thing to kind of watch someone do it, but you know, you don't really learn until you actually do it, yourself. Okay. With that said, this lecture will be recorded. So, I think another valid way to go about this is to maybe just watch it now. And then, later on when it's posted on YouTube, you can kind of follow along where you can pause the video or play it at 2x speed if you want. And so, unfortunately, I can only talk at 1x speed, and, it's hard for me to pause. And so, that's another way to do this as well. Okay. And so, I will say at least from my perspective, I'm a little bit nervous because it's, I know it's a brand new software for all of you guys. And I can't see what's going on your screens. And so, I've done a couple software, walkthroughs, this semester and last semester virtually like this. It's difficult just because it's hard, because if you guys run into issues, it's hard to kind of, see what's up. And especially with this software, because it's a research software, it doesn't have all the nice bells and whistles and things that you would expect in like SolidWorks or something like that. So, there's going to be issues, and, SimVascular is probably going to crash. It might crash on you a couple times, but, it's all kind of part of the process. So, just kind of bear with me today, and, hopefully we can get to a finished model. And then, then we'll go from there. Okay. All right, and so I guess before we begin and before we go into SimVascular, are there any questions that I can answer on the homework or anything that I covered recently that that you wanted to ask? Okay, and so just anytime today you can stop me for questions. Definitely I want this to be interactive, so definitely don't be afraid to speak out. Right. Okay, so our starting point is going to be here. And so if you downloaded SimVascular, you should be able to run it from your computer. And so if you have a Windows machine, just like I kind of showed you in the video, you can basically go to, where you have S in your computer, SimVascular, and then just run that. And then after that, you should get to this screen right here, okay? And so just like I mentioned before too, the other thing that you should have downloaded was the demo project, okay? And so the demo project was a zipped folder, okay? So let me go to where mine is located, right? Right. And so if you open up the folder for that demo project, you should see the following. So you should see folders for images, mesh, models, path, segmentations, and simulations. And you should also see kind of an extra file here called the Sv2d file, okay? All right, so first thing let me show you is just very basically how to create a new project and how to load an image data, okay? And so for this, we already have this project is actually already fully completed. But just because, for your final projects, you're going to be working with, you're going to be constructing your own models. I want to show you how to kind of start from scratch, okay? And so to start from scratch, right now there's nothing. So we've basically just, opened up the SimVascular software. And so the first thing we need to do is create what's known as a project, okay? And so a project will basically hold all the data and all the information that pertains to a single model, okay? And so to create a new project, you're going to go up to the top and you're going to click File, and then you're going to click Create SV Project, okay? Right. And then after you do that, then a window will pop up, and then it will ask you, first it will ask you to give your project a name. And actually, let me go ahead and delete the one that I created earlier, just so I can use the same name. Okay. Right. It's going to ask you to give your project a name and also where you want to save it. Okay. So the first thing to do is go ahead and pick a location on your computer that's convenient to save. So don't save everything on the desktop. I know that's the really tempting thing, but with these kinds of projects where we're going to be creating a lot of files, it really helps to stay organized and to put your folders in the right places and name your folders well. Okay. I know it's tedious. I know it's annoying, and and honestly, I'm probably a terrible person to give you advice on this because normally I'm very disorganized with that stuff. If you ever looked at my grad school computer, then no one would be able to decipher that except for myself. But for this class, I really want you guys to kind of be organized with your files, because we're gonna be producing a lot of files. And so for here, you can see I've put my folder into the folder for this class and into a folder called code, right? So you don't have to use the same structure as me. Just put it in a place where you're going to remember. That's not your desktop. Okay, that's the important thing. Okay. All right, and so let's give this our project a name. And so I'm going to give the project a titled, so I'll call this tutorial project, okay? And then once you give that a name, you go ahead and click OK. And then after you click OK, then you should see that this, this menu on the left here called the SV Data Manager, it should populate, okay? So you should have different sections here for, you know, the images, paths, segmentations, models, meshes, and simulations, okay? All right, so was everyone able to create a project and to get this menu to appear here?
Sorry, Professor, what was the link that you clicked on in the file, in the zip file?
Oh, in the zip file. Oh, I didn't create. I didn't click anything in the zip file. So you're talking about the demo project?
Yeah.
So we haven't opened the demo project yet. So
Oh.
I'm showing you how to create a new one
Sorry.
from scratch. Yeah.
My bad.
No problem. Yeah. So the reason I'm showing you this is because for your final projects, you know, I'm just going to be giving you basically just the medical images. And so you're going to have to create a new project and load the medical images and start from there. So that's why for this, that's kind of the place where I wanted to start. Yeah. Okay. Right. Okay. So then now that we've created a project, the next step here is to load in the medical image. Okay. And so, you know, kind of your guiding light or your guiding pathway should be, you know, this menu right here, okay? And so, you know, these steps here, all these things here in this, all these items here on this data manager, they're basically going to outline all the different steps that you need to do in order to run a SimVascular simulation, okay? So the first step, and so if you're ever kind of lost on what to do, just kind of come back to this data manager and see, you know, what steps haven't I done yet, right? And so the first thing that we're going to do is we're going to need to load the medical image, okay? And so in this case, it's going to be a CT scan. So you remember what a CT scan was from last week, okay? And so to load the CT scan, you're going to right click on images, and then you're going to click add / replace image, okay? And since right now we don't have any images loaded, and so we're just going to add an image here, okay? Okay. And so from here, here you need to open up that zip folder because that's where the medical images are. Okay, so let me back up a bit. Okay.
Wait, how did you get that again?
This menu right here. I right click.
Oh, you right click. Okay.
Yeah, right click. I right click images and click the add / replace image.
All right. Thank you.
Yep. Okay. And so from here we need to load in an image file. So the image file is a .vti. Okay. And so if you've unzipped your demo project folder, the zip folder that you downloaded from SimVascular, and you go inside it, okay, you should see a folder here called images. Okay. And so if you go inside that images folder, you should see that there's a VTI file here for sample data.vti. Okay. And so we're going to click this and we're going to click open. Right. And then at this point, it's going to load that medical image data into SimVascular. Okay. And so some prompts are going to come up here. So the first prompt is going to be, do you want to copy this image file as a VTI into the project? And so we say yes to this. Okay. The next prompt is going to be, do you want to scale this image? And so all scaling means that, you know, it's going to scale some of the dimensions in the image. And so most of the time you want to click yes to this. So go ahead and click yes. And then the last thing is that it's going to ask you for the scaling factor, right? And so don't worry about this just now, and just go ahead and click OK.
Professor?
Yep.
Say you didn't unzip. Is there a way to unzip it now?
Oh yeah, yeah. I mean, you'd have to kind of unzip it manually. So you have to go to your you know, your kind of Windows Explorer and go to the zip folder, and then just use like WinZip or something like that, WinRAR, to unzip that folder.
Okay, cool. Thank you.
Yep. Mm-hmm. All right, and the last thing that you're going to do is you're going to give your image a name. And so I'll call this tutorial image. So the name doesn't really matter all that much, but make sure you give it a descriptive name so that you can kind of remember it for later. Okay. And then after you give your image a name, you can go ahead and click OK. And SimVascular is going to think for a minute. And then you should see the medical image loaded here. Okay. All right, so was everyone able to load in the medical image? Okay, great. Okay. All right, so what you're viewing here is actually, a CT scan of a real live person. So, this was a person who I've never met him, but I assume he volunteered his scan for science. So thank you, whoever this person is, right? And you're seeing basically a cross section of his torso, right? And so remember what we talked about on Tuesday is that a CT scan is a volumetric data set, right? And so what you're viewing, so let's look at kind of the bottom right pane here. Okay, so what you're viewing here is kind of the box of this person's torso. Okay, and we're viewing it at different slices. Okay, and so what you're viewing right here is called the four view. And so what that means is that you're kind of viewing the image data in four different planes here. Okay, and so in the bottom right, that's the 3D view, and so that's where you can kind of rotate the sky left and right. Okay, and then each of these other views right here are different cross sections or different slices into that 3D data. Okay, and the colors here kind of indicate which view that you're looking at. Right, so let's look at the red cross section first. Right, and so the red cross section is given here. Okay, in the top left. And you'll see that this red cross section is labeled axial, okay? And so that's the medical term used for views along this plane, okay? And so if you kind of, stand up straight and you kind of view yourself as kind of a rod, right? And so the axis of yourself is kind of a line that's drawn from kind of your head to your toes when you're standing up straight, okay? And so an axial view is basically a view that kind of slices that plane, perpendicular to that, okay, perpendicular to that axis, right? And so basically, when you're viewing this axial view, you can kind of almost think of it as you're viewing someone from the top bottom, okay? Right. All right, so next we have the sagittal plane, which is the green one here, okay? And you see the green one here is this one right here. So for the sagittal plane, it's like you're kind of looking at the person from the side, but obviously you're viewing a cross section of their insides, okay? And then the last plane right here is the coronal plane. And that's like as if you're viewing someone from the front, okay? And so each of these different cross sections, we're viewing them from the image data, and they're going to be useful for different things, okay? All right. So any questions so far on the on viewing the medical image data? Okay. And so the next thing that we'll go over is how do we change these views, okay? Because so you probably seen me, you probably just saw me do it just myself, right? And so the way that we can move these cross sections up, there's a couple of different ways to do it. And so say you want to view kind of a higher cross section here. One way that I like to do this, and this is only possible if you have a mouse with a mouse wheel, is you can just mouse over that section there and just scroll up and down on the mouse wheel, okay? And so you can see right now I'm scrolling up on my mouse wheel on the axial plane, and you see that plane is kind of moving up the person's body just like that, okay? And so as we're doing this, we're basically moving closer towards their head, okay? All right, so that's one way to change the views of these planes, okay? Is to basically use your mouse wheel, okay? But if you don't have a mouse wheel or you're working on a trackpad, another way that you can change it is from this this image navigator here in the bottom left. Okay. Ah, so yes, so if you have a mouse pad, you can do it with 2 fingers scrolling too. Yeah, that's a good point. Okay. And so another way you can do it is you can do it from this bottom plane. So these sliders right here, control which plane that you're viewing. Okay, so let's change the axial plane right here. So what you can do is you can just click this slider and just move it, and this will also make the axial plane move. Okay, and so with that, you can see that we're moving to different parts of the body, just like that. Okay. And so you can go ahead and play around with this a little bit. So you can change the different cross sections, and you can see the different cross sections of this person's body. Okay, but the place that we're going to be focusing on for this tutorial is actually going to be the part that show up bright white. Okay, and so you can kind of see it from the 3D view here that there's parts here that show up bright white, and that's actually the person's aorta. So that's actually a big artery in this person's body. Okay. And so what happened for this person was there was they took a CT scan, and they injected iodine into this person so that the blood vessels show up really bright white, okay? And the blood vessels are what we're going to be focusing on for this tutorial, okay? Yeah. So actually, this part of the image right here, in the coronal plane, this is actually their kidneys, and so you can actually see a cross section of their kidneys, and so because of the contrast agent too, the bones are there. The bones are there too, but you can see the bones are showing up very light gray, because we're focusing just on the contrast agent. Okay, so those contrast agents are they really make a big difference on how you can view the different organs. Okay, because if you just took a regular X-ray without any contrast, kind of like we talked about on Tuesday, the only thing that you would see is the bone, because the bone is the bone has all the calcium. But because we injected the iodine, then we're viewing the blood vessels instead. Okay. Okay, so any questions on this so far?
Professor, I have a question.
Sure.
You said that is a CT images, that's right?
Correct.
Can we, can we use the other things like MRI or something like that on this software, or we can just use the CT images?
Yeah, no, you can use MRIs too. And so this particular data set just happens to be CT, but MRIs can also be loaded in here. So typically, so that file format that we talked about earlier, the VTI, you can save MRI images as VTI files as well. So you might have to do some conversions because the world of medical images is kind of weird, because like depending on which company made the machine, it might output the files in a specific format. But if you can convert that file format into a VTI file, or I think the other common file format is called DICOM. And so DICOM is a file format for medical images too. And so SimVascular can handle both. It can handle both VTIs and DICOMs. And so you can load either of those into SimVascular. Yeah. Mm-hmm. All right. Okay. And so viewing the medical images is fun. And so not gonna lie. So the first time I did this, I spent a long time just scrolling around and viewing this person's inside. Okay. But we're not just here to view we're not just here to view the images. Eventually, we want to run a CFD. Okay. And so in order to do that, the first thing we need to do is to define the geometry. Okay. Because right now we can kind of visually see, where the vessels are, but we need to construct our CAD model for this geometry in order for us to run a simulation. Okay, and so that's kind of the subject of today's workshop, is to how do we actually generate the geometry, and how do we basically how do we generate our CAD model for this person's blood vessels. Okay, right. And so to do that, we're going to progress along these 3 steps right here. Okay, and so the first step that we're going to do is called paths. Okay. And the next step is called segmentations, and then the last step is called models. Okay, and then everything else is going to be the subject of our second workshop. Okay, but let's start with paths. And so paths, what that is the first thing that we have to do, because these vessels are kind of follow a very interesting and very non-straight geometry. The first thing that we have to do is actually define the centerline paths. Okay. And so if you can imagine, in all the blood vessels here, there's a path that we can draw down the center of all those vessels, okay? And so the first thing that we have to define for the computer is that centerline path, right? And so we're going to create a new path. And so we're going to right-click paths right here, and then we're going to go click this option here for create path, because right now we don't have any, okay? Right. And so after you click create path, then you're going to open up this menu here, and then we need to give our path a name. Okay. And so this step is very, people think it's very minor, but it's actually very important. And so when you name your paths, you want to make sure that you give a name that's descriptive of what that path is going to represent, right? And so usually the naming convention that's used is you name your paths after the blood vessel that you're trying to model, okay? And so this is really important because I've seen people, use SimVascular and they just name their paths, path 1, path 2, path 3, path 4, path 5, which is fine if you only have a model with 5 different paths. But I'll show you some other models. And so if you have a model like this, and you can imagine, each of these vessels here is an individual path, you're not going to remember what path 57 is, right? And so you want to name these blood vessels, these paths, to something that's, that's descriptive, okay? And so for this particular model, this is a scan of someone's torso. And so the main blood vessel that we're going to be working with is the aorta, okay? And so remember, the aorta is the biggest blood vessel in your body. And so we're going to call this path aorta, okay? Okay. And so after we name the path, we can see now that we've created a name right here. And so if we double click this, then we're going to open up a new menu right here called path planning, right? Okay. And so once you open this menu, so I don't know if it's going to do that for you too, but it'd be good to kind of adjust this so that the majority of your view is on the 4 images here, okay? Because we're going to be working mostly with the 4 images, the 4 image planes here when we're defining our path. Okay. So has everyone been able to create a new path and open up this menu here?
It's just kind of hard to have the 4 images since I have split screen right now. I have Zoom on one side.
Oh, okay. I see. Yeah, maybe. Yeah, that's difficult. That's always the difficult thing with this, is that you can't. It's hard to have Zoom and the software open at the same time. But yeah, try to make it so that you can view the 4 images kind of as big as possible, because that's going to be the most useful thing. Yeah. All right. Oh yeah, you can do that too. So if you have another device like a phone or an iPad, you can open up Zoom on that too. Unfortunately, no. Unfortunately, we can't ask the school to do that. They don't even give me a dual monitor setup, so I had to pay for my own my own monitors. Okay. All right. And so now, we're going to go about the business of drawing a centerline path for our vessel. Okay. And so here's a rule of thumb. So because this is where you're probably going to spend most of your time in SimVascular is drawing these paths, because this is probably the most difficult part. Okay. And so normally, the way this is going to go is we're going to be basically putting down points, and so you can almost think of them as like breadcrumbs into our image here, and then the path is going to follow those points. Okay, so it's basically going to be like connect the dots, but in 3D. Okay, and so basically the idea is that we want to place these points in the middle of the blood vessels, and then have the path kind of follow those points so that it follows the centerline path. Okay. And so you have a lot of options here because you have, literally 4 different views. And so, the question that I think most people have is, which view do I put down the points, and kind of what are the best practices for doing that? Okay. And so here's kind of my rule of thumb for the points. Okay. So actually, let me kind of back this up here. Let me kind of do this like here. Okay. And so, I'm going to draw your attention to kind of these kind of white areas kind of near the top of these images here. Okay. So these white areas, they represent the blood vessel, because remember, this is where the iodine was injected. And so we want to put our path points in the middle of these white sections, right? And so kind of the best rule of thumb that I like to do is we're basically viewing the same blood vessel in 3 different views, right? So we're viewing it from the side, we're viewing it from the top, and we're viewing it from the front right here. Okay, so 3 views of the same blood vessel, right? And so usually what I like to do is I like to work in just one of the views, and I like to work in the view where I can see the cross section of the vessel really, really easily. Okay, because ideally what you want is that you want your blood vessel to go, maybe down like this, and you want the view that kind of slices that blood vessel kind of in right perpendicular to it. Okay, so you just see the cross section, because this gives you the easiest time to kind of, put the path points right in the middle of the vessel, right? And so for this particular person, since, we're doing the aorta, and we know the aorta kind of runs from your heart down to your legs, right? And so the best view for this is actually going to be the axial plane, okay? And so to start, we want to start kind of at the beginning of the vessel. And so in this particular case, the vessel starts at the top of the image set. And so you want to make sure that your axial slider here is somewhere around like 480. So let's start with 480 like that. Okay. And so normally you don't want to be at the very tippy top of the image data, because the way medical image data works, there's some weird stuff that can happen near the edges. And so we want to be a little bit down from the edge. So if you can see, the maximum value for this is 511. And so let's start at 480, okay? Because that's kind of a good place to start, okay? All right, so is everyone at axial plane 480 and ready to start putting down points?
Yes.
Okay, all right. And so the way this is going to work is that if you look into your axial plane right here, you should see some crosshairs, right? Oh, and if you want to zoom in to kind of give you a better look, you can zoom in by, it's weird. You zoom in by holding right click in this image, and then you either move your mouse up or down, okay? And so if you want to zoom into the vessel here to kind of give you a better view, then that's how you do it, okay? And then to pan, or to basically move it left and right, you hold down the mouse click, or you hold down the mouse wheel, and then you move left and right. But you don't have to do that. So you can just work in this view. You just have to be very dexterous. Okay. Okay. And so in the axial plane, what we want is we want to move the crosshairs to be kind of right in the middle of the vessel, right? And so it doesn't have to be absolutely perfect, but try to get as close as you can, because the closer that you get, kind of the easier that it is later on. Okay. All right. So once you have the crosshairs in the middle of that vessel, then you're going to come to the right of the screen right here, and you're going to click this button for add. Okay. Whoa. Okay, so that's new. And what you should see in the 3D view right here is that you've added a path point. And so normally it's not a big block like that. Normally it's more discrete. But that's your first path point there. Okay. And so we placed that path point basically right in the middle of this vessel. So actually, let me see if I can change this. No, let's see, point 2D size. No. Okay. And so we'll just kind of have to bear with that. I'll have to talk to the dev team and say why the heck this thing is so big. Okay. But after you place the first path point, you should have your first path point right here. And this right here is the XYZ coordinates of that point. Okay. So was everyone able to get their first path point?
Yeah.
Okay. All right, great. And so now what we're going to do is we're going to follow the vessel down and then put more path points down. Okay. And so you can either use your mouse wheel or you can use the slider here, and you want to move the axial plane down. Okay. And so I'm going to move the axial plane down to coordinates. Let's do 460. Okay. Because you want to move a decent amount down, but not too far down. And then now we're going to place our second path point. Okay. And so just like before, we're going to work in the axial plane, and we're going to find the middle of the vessel, and then we're going to click add. Okay. Right. Yeah. You want to make sure that so in order to place path points, you want to make sure that your aorta is highlighted down here. Okay. All right. So you can see here our second path point is added, and now we can keep adding path points. So now you can go down about every 10, 15, 20. It doesn't have to be exact. Okay. And so I'm going to go down every 20. And so now my axial plane is at 440. And so you can see that the cross section is moved. And so I'm going to move my crosshairs to the middle right there as best I can with this crappy wireless mouse that I have, and then click add. Okay. And once you guys go ahead and keep doing this, for a while. Okay. So I'm going to keep adding path points about every 20 axial slices. And then if you keep doing this, eventually the path is going to split. Okay. So why don't I give everyone a chance to kind of work on this on their own? Just keep adding path points, going down on the axial plane until you reach the point where they split. Okay. Right. And then if you want to see your path kind of updating, you can go into the bottom right 3D window right here. And you can see that your path is being created here. Okay. Right. And so if you have a mouse, don't be afraid to zoom in to kind of give you help you out, finding that center. Okay. So it's been a while, so I forgot which axial slice where it actually splits, but once I get there, then I'll let you guys know.
So Professor, do we do it until we reach the bottom?
No, so eventually the path is going to split. So I'll let you know when that is.
Oh, okay.
Yeah, so you'll see that this kind of big blob will split into two blobs. And so once it kind of splits into those two blobs, then we'll come back and then I'll let you know what to do there.
Are those two blobs where they bifurcate?
Yes, exactly. Yeah. So the when you see two blobs, that's a bifurcation. Yeah. So you want to be careful. Oh, go ahead.
Sorry. How did you change the size of the blocks again? Because mine are huge.
I think what I did was I right clicked aorta right here and I clicked 0.3D size and I changed this from 1 to 0.1. Yep. And then if that doesn't work, click 0.2D size and I think this was 10 and I changed this down to 1. Yeah.
How do I zoom in again?
So you hold right click and then you move your mouse you move your mouse up and down.
Thank you.
Mm-hmm. Okay, so once you get down to axial slice around 190, 185, that's when the path splits. Okay, and so I'll give people a couple minutes just to kind of reach this point. No question. So so put a point right before it splits, and then we'll talk about what to do after it splits. Yeah. So get right up until the split, and then we'll pick it up from there. Yeah. All right. So how's everyone doing putting down their path points? Was everyone able to get to the split?
I'm in 180 and it still hasn't split it yet.
Oh, really? You don't see this at around 180?
Oh yeah.
Yeah. Okay. Yeah. We'll stay there. Yeah.
Okay. I was looking at 3D one. I thought it was supposed to like have two different paths or something.
Oh, I see. Yeah. Yeah. Patrick made a great point in the chat. So make sure you're saving your work. So make sure to constantly do that. And so to save your work, there's a big button right here with a floppy disk. So just click save, and then that saves your project. Okay. Yeah, because the thing with research software is that you never know when it's going to crash on you, unfortunately. And so it's always pays to save your work often. Yeah. Because there's no worse feeling than working on something for an hour and then losing all of it because SimVascular just didn't like you that day. Okay. So just in the interest of time, I am going to move forward. Okay. All right. And so once you get to a split like this, right? So this is very common in the cardiovascular system, just like as we've talked about before. And so vessels are going to bifurcate. Okay. And so at this point, what we're going to do is we're going to basically just pick a side and then follow it down. Okay. And so usually when you're making your paths, and you're starting a path, usually the best thing is to basically follow it down, follow it down one vessel all the way until you reach the end. Okay. And so at this point, you can choose either one. So actually we're going to do both eventually, but we want to continue this path until we basically reach the end of the image data. Okay. And so I'm going to pick the right path, but you can pick the left path if you want, it doesn't matter. We're going to model all of it the same, but the point is, you just pick one and then you just keep going down that vessel. Okay. And so I'm going to keep adding points here. Okay. Right. And then eventually you're actually going to reach a point where, the vessel is going to look like a very, very big blob. Okay. And so what's happening there is that the vessel is actually changing directions. Okay. Because all the way up until this point, the vessel has just kind of gone in one direction. But actually, after it splits, it kind of does this weird thing where it kind of splits and then changes direction and then it goes back down again. Okay. And so when you reach the point where it's kind of a very, very big blob, it's usually good to switch to a different view. Okay. Because remember, we usually want to work in the view where we can see the cross section of the vessel kind of most clearly. Okay. And so I think if I go down a little bit more, yeah, so if I go down a little bit more, so once you get to the point of like axial slice 164, the vessels actually going are parallel to the axial plane, almost parallel. And so kind of the best way to actually do this now is in the coronal plane, because in the coronal plane, you can see right here, we can see this cross section of the vessel a little bit better. So I know it's probably a little bit hard to see just because I've seen this data like a million times, but you usually want to work in the view where the vessel cross section looks as close to a circle as possible, right? Because generally blood vessels cross sections are circular, and so you want to work in the view where it looks like that. Okay. And so I'm going to go in the middle right here. Go ahead and add a point, right? And you want to keep doing this until you reach the bottom. And if the vessel splits again, you can just pick a side. Okay. Okay. And then just go down as far as you can, right? Eventually, what you'll notice is that the image starts to get really fuzzy, and that's because the vessels are getting a little bit too small for the image resolution to pick up. Maybe I'll do one more. Yeah. Okay. All right. And so after you're done with your path, you can go look in the 3D view and you can view kind of your path just like that. Okay. Right. And so for this tutorial, you don't have to go all the way to the bottom. Actually, it starts to get a little bit hard once you get around axial slice 100. It starts to get a little bit hard to view the vessel because the the resolution starts to deteriorate there. And so if you can get around axial slice 120 and place a path point there, that's usually kind of a good place to be. Okay. All right. And so with that, this is our first path. Okay. So is everyone able to get a path like this?
Yeah.
Okay. All right, great. All right, so that's the first step. So we have our first path already. Okay. And so eventually, we're going to come back and we're going to get the other branch of that vessel that branched off. But for now, let me show you the next section of SimVascular, which is segmentations. Okay. All right. So at this point, what we've done is we've traced out the centerline paths for the vessel. Okay. Which is great. So that tells us, the general trajectory of the path. But we also need to define out the cross-sectional area. Okay. And that's basically the point of the segmentation. And so just like we did for the path, we're going to right-click segmentations. Okay. And then after we right-click segmentations, we're going to click this button here called Create Contour Group. Okay. Right. And then after you create the contour group, you're going to see a menu that comes up right here. Where it's going to ask you for two things. So the first thing it's going to ask you for is the path. Okay. So right now we only have one path, and so that's the only option that we have. And then the other thing that it's going to ask us for is the group name. Okay. And so from here, just like before, you want to give your things descriptive names. And so usually what I like to do is I usually like to give my group the same name as my path. Okay. And so since my path is named Aorta, then I'm going to give my group name Aorta as well. Okay. And actually by default, if you leave this blank, then the group name will actually match the path. Okay. But I'm going to call this Aorta. Okay. Right. And so after you do that, you'll see a new entry under segmentations appear. And so that's going to be our Aorta Segmentations. Right. And so what you can do from there is you can right click or double click that, and it's going to open up this new menu here called Sv2d Segmentations. Okay. And if your Windows like mine and your SimVascular is doing something weird and you still have the path planning window open, you can click this X right here next to SV path planning to close it, because we're not going to need path planning right now, at least not for a while. Right. Okay. So was everyone able to open up or create a new segmentation group? Okay, great. Okay, and so from here you can see our 3D view has changed. Okay, so now instead of 4 views, now we have 3, right? And so if you look at kind of the big one here, what you should see is you should see your path, and so this is the path that you just created. Okay, and you should see a slice now that's going perpendicular to that path. Okay, and so what you're viewing now is you're basically viewing the same image data but sliced, perpendicular to your path. Okay, question. Yeah, so it just happens to be a triangle right now because we're kind of slicing near the edge of the image data. And so that's why I kind of talked about earlier. It's usually not a good idea to start pathing right at the tippy top of your image data. You want to come down a little bit because eventually you're going to start to add segmentations here. Okay. Okay. And so now let's actually start working in the in this top view right here. Okay. And so you can see in the middle of this image here. Yours will probably look different because everyone's path is probably going to be slightly different from each other. But what you should see kind of near the middle of this image is kind of a bright circle. Okay, and this bright circle represents our vessel cross section. Right, and so the point here, or what our goal here, is to basically go along this path and basically trace out the vessel cross section at various points along the path. Okay, and so you can see there's a lot of options here for this. And there's each of these different options has its place, but we're going to focus on just the ones that are the most useful. Right? And so the first one that I'm going to show you guys is called the machine learning segmentation. Okay, and so the reason it's called machine learning is because this is a tool that was actually developed by a colleague of mine to help kind of draw these segmentations. Okay, because what the machine learning will do is it'll look at this cross section right here, and it will identify where the vessel is, and then draw a shape, for that cross section. Okay, and so what you're going to want to do is you're going to want to make sure that you're on a view where you can see the cross section well. Right, and if you don't see the vessel cross section well, you might have to move this slider right here. Right, so what this slider does is that it moves you along the path. Okay, and so if you don't have an image like mine where you can see the vessel cross section very clearly, make sure to move your reslice window here to a point where you can. Okay, and then once you see the cross section here, all you have to do is click machine learning, and then this thing will pop up. Okay, and so it'll say that the machine learning segmentation data will now be loaded, which will take a minute. Okay. All right, so give that a couple minutes. I didn't know this was a thing. So this is off script. Yeah, so this is this part is it's going to be a little bit heavy, especially loading the machine learning stuff. So I think what it's doing is that it's loading its machine learning database for this. So give it some time. So it'll probably say that SimVascular is not responding, but it's still doing stuff. So just have faith. Yeah. Yeah. So this is the part where if you have a good computer, this really kind of helps you out. Okay. Okay. And then once it's done, what you can see here is that it's oh dang, yeah. So if the reslice frame isn't working, then yeah, then yeah, it's going to be tough for you to run SimVascular. So maybe we can talk offline to see what we can arrange for that. Yeah. Okay. And so what you can see here is that it produced this red line right here. And this red line is what it's supposed to be is that it's supposed to, go around the cross section of the vessel. Okay. But you can see here that this, what it produced actually wasn't that good. Okay. Because what we want this red line to kind of hug around this white section of the vessel as closely as possible. Okay. And so since this contour isn't that good, I'm going to go ahead and delete it. Okay. And instead, I'm going to use a different tool. Okay, so actually, this is a good chance to showcase the other, I think, useful tool here, which is basically draw it yourself. Okay, and so when the machine learning doesn't do it well for you, the best thing is just to kind of draw it yourself. Right. Yes. So if the red circle doesn't appear, then you can click machine learning again, and then it will appear. And so hopefully your guys has produced a better cross section. So if your red line was hugging your vessel pretty well, then you're good. So you don't have to delete it. But since mine didn't really produce a good result, and so it kind of produced this kind of ugly thing, I'm going to delete it and then just draw this manually. Okay. And so if you're like me and you had to draw this manually, here's basically how you do it. Okay. And so for this, you might want to zoom into your blood vessel just so you can see it well. And then what you're going to want to click is this button here for Spline Poly. Okay, and so Spline Poly is basically going to allow you to draw your cross section manually. Yeah. Oh, to zoom in, the way that you do that is you right click and then you drag your mouse. Yeah. And then to pan, you hold down your mouse wheel and then do that. Okay, so I'm going to click Spline Poly. And then what you can do, and then what you have to do here is basically you have to manually click around the edges of your blood vessel here. Okay. Okay. And so you're going to basically go around, try to hug the surface as closely as you can. Okay. And then once you kind of make a full circle like this, you're going to hit F on your keyboard, and then that's going to complete the process. Okay. And so from there, you can see that, we've created our first segmentation. Okay. Right. So was everyone able to create a segmentation either with machine learning or with Spline Poly?
Yeah.
Okay.
Why does yours have like those green bubbles?
So the green bubbles are there to help. That basically indicates where I place down points. So that's because I did mine manually, so mine has the green bubbles. But I think if you did yours with machine learning, it's going to be different. Yeah.
Okay.
Yeah. So the question is, what's the difference between poly and circle? So circle literally just draws a circle onto your vessel. And so if you draw a circle, if you pick circle, it'll just draw that. But then a spline poly will let you basically trace out kind of manually around the circle.
What's the best practice for this? Should we stay in the white or should we go like in the gray and black?
Yeah, so that's a good question. So actually, it's still kind of up for debate. And so what I like to do is I like to actually go right in the little gray area. So like, you can see it's bright white and then it kind of turns into darker color. So if you kind of go in the region right in between that, to me, that's the edge of the vessel. But actually, there's a lot of variations between what people actually do and for that, but that's generally what I like to do. Yeah, so the question is, why would we use one over the other? So in terms of accuracy, so A lot of times, if the machine learning, method works for you and it produces a good cross section, then I would use that because it's the fastest thing. But what you'll see, so you won't see it here because this resolution is actually pretty good. But for a lot of the other images, especially ones with the smaller vessels, you'll have blood vessels that literally show up as just like 4 pixels on your screen. And so, obviously your blood vessel is not a square, right? And so in those cases, you might either have to use a circle, or you might have to draw something manually just to make sure that you get a cross section that makes sense. Yeah. And so the driving factor is kind of image resolution. Okay. And so now that we've created a cross section at one part, now we need to progress down the path and create other cross sections. Okay. And so you can do this a couple ways. And so you can either scroll your mouse wheel on this kind of axial view right here, and you can see that it's progressing here. Or another thing that you can do is you can just use this reslice slider right here and just go to different cross sections. Okay. And so let me go to cross section 5. Okay. And so you can see that there's a different cross section here. Oops. Right. And so from here, let me try the machine learning again. Click it again. Okay. And you can see it does, a decent job. Okay. And so you can see here it's it's not perfect, but it hugs the vessel at least better than what it did before. Okay. So I'm actually going to keep this one. Okay. All right. And so what you're going to do is you're going to progress down the vessel. Okay. So go in increments of about 5, I would say, and then keep using the segmentation tools to trace out your vessel cross sections. Okay. Because if you look in kind of the 3D view, what you're seeing here is your collection of different cross-sectional shapes right here, okay? And so the goal is to basically go down the path and basically define what the cross-section looks like at all the different points in your path, okay? And so I'm gonna go ahead and do that. And so, go ahead and go all the way down the path for you guys. So the machine learning is not working great for me. And so, if the machine learning is not working great, another option could be the level set. Right, or not, right? Right. And so use a combination of either the machine learning or the spline poly to basically create your cross sections. Okay. Yeah, so the machine learning is actually not doing that great for me because normally I would, I would say this is not that good, but just kind of in the interest of time, I'm just going to keep kind of going on with this. Yeah, but for your projects, you would definitely want to, have a more accurate cross section here. Yeah, because something like this isn't that great because you can see here that, on one side of the blood vessel, we're kind of overshooting it, but on the other side, we're kind of undershooting it too. So, for your projects, this probably wouldn't be something that's good, but just kind of just to make sure that I get through everything today, I'm just going to roll with these guys for now. Yeah, a lot of these are not that good, but it's okay for this one. Okay, and then eventually you'll reach the end of the path. Okay. All right. So how's everyone doing with their segmentations? Anyone running into any issues? Oh, the blue boxes. No. Yeah. So the blue boxes. You mean these path points? You might have to make the your path bubble smaller. And so the way that you do that is you right click paths right here, and you click a 0.2D size, and you can either change, I think this used to be 10, so you can change this to 1, right? And then you click 0.3D size, and you make sure that this is 0.1. I think that that changes the size of those things. Yeah. Right. Yeah. So if the machine learning method is working fine for you, then that's great, because that's you know, that's the preferred one, because it's nice because it's fast, right? Okay, so how's everyone's cross sections looking? So is it looking good? Okay. All right.
Wait, is yours going? Is your path going through the 3D view?
Oh yeah, because this is you know, the reslice window. So this is the basically we're slicing the image data along the path like here. So as you're placing the cross sections or the segmentations, you know, we're doing it at different locations, just like that. Yeah.
Oh, okay, got it.
Yeah. Mm-hmm. Right. Yeah. So if you so if the machine learning, you know, I thought, you know, it was interesting because one of my graduate students was using a machine learning method you know, earlier this year, and it seemed to work a lot better for him. So this is actually kind of strange for me. So maybe I'll hit up the devs and see what's up. Okay. And so now, you know, so if you're able to do segmentations to the end, that's great. But if not, you know, then maybe you can kind of just tune in and follow along. So and so I'll say that this is you know, I don't think we'll have time to cover absolutely everything, because there's one really important point I want to cover, you know, and I think I'll probably do that next Tuesday. So next Tuesday, I think we'll probably finish up this workshop, just because it was a little bit too much to cover in one day. Okay? But the last thing, you know, one of the things I wanted to cover for sure today was how to actually create your CAD model from this. Okay, because right now we don't have a CAD model yet. What we have is a line, and we have a bunch of shapes along that line, right? And so the way that we're actually going to generate this model is we're actually going to connect all of these cross-sectional areas together into what I like to call I like to call it like 3D connect the dots. My advisor always hated it when I called it that, but to me that kind of makes the most sense. Okay. And so to do that, we're going to use this this tab right here for models. Okay. And so just like we've done before, oops, not for meshes. We're going to right click the models in our SV data manager, and then we're going to click the button for create model. Okay. Right. And then after you create the model, it's going to ask you to give your model a name. And so just like before, you know, make sure you give your model a good name. But you know, unlike before, you know, this model is actually going to encompass all of our blood vessels. Okay. And so right now we just have one blood vessel. So you know, it's you know, it's you know, not you know, it's not a collection of blood vessels. And so I'm going to call this tutorial model. Okay. Right. And so after you do that, you'll see new tutorial model show up under the models tab here. So just like before, we're going to double click that. And then we're going to, you're going to see this menu right here. Okay. Right. So was everyone able to create a model and then get this tab for SV modeling right here? Okay, great. Yeah. Yeah, a good GPU, I think, would help. Okay. And so, oh, actually, yeah, where's our segmentations? Okay. And so the way a model works is that it's we need to choose all the segmentation groups that are going into the model. Okay. And so actually, I thought I should ask you kind of before this. Let's see.
Professor?
Yep. What's up?
Do you mind showing how you got that SV modeling window again?
Yeah. And so let me go ahead and remove this. Right. And so to get that SV modeling window, you're going to right click models right here. And then you're going to click create model.
Mm-hmm.
And then it's going to ask you to give your model a name. And so I'll call this tutorial model. Okay. And make sure the model type here is selected as polydata. Okay. Okay.
It needs to have an underscore, huh?
Yes, yes, yes. Oh, yes. That's something that's important too. So because SimVascular here was it's developed on Linux. Linux really hates spaces in between stuff, and so if you're going to write a space like in between, you know, a name of something, you should use an underscore instead. Yeah. Okay. And so at this point, you know, and we have this SV modeling window here. Okay. I had to move my the Zoom thing so I could see this, right? And so what you're going to click right here in the SV modeling window is this button up here for Create Model. Okay. Right. And so after you click Create Model, then you know, this new menu will pop up, and this should list all of your segmentation groups for you. Okay. Right, and so at this point, we just have one segmentation group, so we just have aorta. And so we're just going to select this, okay? But I think what we'll do, so we'll probably start it today, and we'll probably finish it up on Tuesday, is that when you have multiple vessels or multiple segmentation groups, you can kind of select all of them from this list, okay? And so from here, the only thing you have to do is just to make sure that aorta has a check mark here, and then you're going to click OK. Okay. And then after you do that, you should see that your CAD model is constructed, okay? And so if you want to view, so you should see the CAD, your CAD model in the bottom right 3D view right here. And so if you want to maximize this, you can go to this upper part right here, and then click on this square right here, okay? And then that will basically maximize this view, okay? And if you want to turn off all the image slices, what you can do is you can click this button right here, and then uncheck the part for show crosshair, okay? And then what you can see right here is this kind of hunky-dunky little tube right here is the vessel that you just created, right? And so if you want to see how I manipulate this view, you know, here's how I did it. So probably you're starting out from this view right here. So you have your 4 views, and you have your you know, your cross section here. And so in order to maximize the 3D view and to maximize any of the views, you can click, you know, this square right here, okay? And then you can click this, this button up here for show crosshair. Okay. All right, so it looks like people are getting some errors. So what are the errors that you are, what does the error say that you guys are getting? It just says error creating model. I see. Okay. I see. Okay. And so probably what's happening is that if you look at your segmentation, so if you look at your cross sections, are any of them like overlapping each other? So if you so you don't need the number of sampling points because it's because by default it picks something good for you. So if you just leave it blank, then it's fine. Yeah. Yeah. And so so if you have any segmentations that are overlapping each other, yeah. So if you have any that's overlapping, you want to delete one of them that's overlapping because basically what it's doing is that it's progressing from segmentation to segmentation and then kind of filling in all the space in between. And if you have any that's overlapping, it kind of gets confused because it kind of fills in the space and then it has to kind of go back. And then when the model kind of has to overlap each other like that, then that's when it kind of throws an error. So if you have any segmentations that are overlapping, just go ahead and delete one of them. And just to make sure that all your segmentations kind of look, you know, kind of like this, right? And so none of them are kind of none of them should be overlapping like that. Yeah, it's a common thing. So usually when people first make their SimVascular models, they have segmentations that overlap like that. Yeah, it's tough because, you know, when the vessel turns, it's hard to get segmentations in there that don't overlap. So you can see here I actually come pretty close. So you can see these cross sections just based on how the path goes, they're almost overlapping here. So that tends to happen when you're going around turns in your cardiovascular system. And so you have to kind of be careful about where you place your segmentations around those curves, just to make sure that you don't get overlapping like that. Yeah. So were some of you guys able to get a solid model that looks like this? Of course, yours is going to look different. Everyone's model looks a little bit different. It depends on how you created your path and how you created your segmentations. But you should have a solid model that looks like a tube, like some kind of hunky-dunky tube like this. Yeah.
What was the button that you pushed again to hide the 3D view?
Yeah. So the I went from here. So so after I maximize the 3D view, there's this little crosshair here. And so I can't do it with Zoom open. And so if you click this this little crosshair, then there's an option here for show crosshair. Yeah. And so if you uncheck that, then that hides the medical images. So you can just focus on just your solid model. Ah, CATIA surfaces. Great. Okay. Yeah, so I'll give you guys a couple minutes. You know, we're kind of near the end of lecture today, but I want to at least make sure that everyone was able to get kind of a surface like this. And so I think probably we'll talk about branching vessels on Tuesday, because branching vessels, there's actually a lot of complications to that. So I think, you know, I want to really take my time and explain that. And so is anyone still having error messages or still having issues creating their model?
Why does my aorta look like a zebra?
Oh, it looks like a zebra.
Well, like the beginning looks like yours, but then is it just like the graphics probably?
Oh yeah, it's probably a rendering thing. So it's if your surface doesn't look smooth like this, then I'm guessing it's a GPU graphics card issue. Yeah. But just in case, go ahead and take a screenshot and then email it to me, and then I can take a look. Yeah.
Okay.
Yeah.
Thank you.
Yep. All right. So how do we get the model by itself? Yep. So and so you're probably looking at this 4 views. Yep. And then you click on this square right here to maximize the 3D view. Right. And so there's basically a square. So this basically is like maximized right here. Right. And then you click this cross, and you click this little button right here, and then you click show crosshair. All right, Ronald. So you said you click create model, but nothing happens. So when you click create model up here, then this window here doesn't show up. Oh, do you have a segmentation group over here? Is your model type poly data?
Yes, it is.
Oh, it's poly data. Does the program seem like is it lagging at all, or is it or can you still click like buttons and stuff like that?
Yeah, it's not frozen.
Okay. Maybe go ahead and try deleting that model. So go ahead and right click. Let me cancel this. Go ahead and right click your tutorial model here. Go ahead and click remove.
Okay.
And then go ahead and try to create a model again. So just right click models, create model, give it a name, and then try clicking create model up here again. Is the button grayed out like this, or is it
What button?
the create model button here in the top right?
Oh yeah, it is.
Okay, yeah. So you want to make sure that tutorial model here is highlighted, right? And so in your data manager, this is highlighted, and then now the button should be clickable here.
I deleted it, so.
Okay, yeah. Go ahead and create a new one. That's fine.
Oh, okay. I'm an idiot.
Yeah. It's a bit confusing, because in order for this to be active over here, you have to click, the correct object here. Because if you're clicked on like the path, then everything here is grayed out and you can't click it. So yeah, that's one thing that's kind of annoying with how it's implemented.
Okay, thanks.
Yours look like a churro. Yeah, it's everyone's is going to look it's going to look a little bit different, just because it's everyone segments a different way. And so we went through this really fast, and so that's why I use the machine learning stuff. But normally if we go to the segmentations here, you know, and we're looking at the different contours. And so let's look at this one right here, right? And so this one's actually not bad because it's, you know, it hugs it pretty well. But normally, you know, you would spend actually the majority of your time, you know, first of all, making sure that your path is good, but also making sure that your cross sections here are drawn well, right? And so normally, you know, I wouldn't roll with something like this because it's not a good drawing of this. And so if I saw this normally, I would actually take the time and click Spline Poly and then draw this out manually because, you know, you want to make sure that you get your cross sections really well. And so for this tutorial, you know, I know we went really fast and we used all the fast tools, but you know, for your projects, you know, really take your time to make sure that, you know, your paths follow your vessels really well and your cross sections trace out that cross sectional area really well too. Yeah, I want churros too.
Do you know if you can edit these cross sections made by machine learning?
Yes, you should. So actually, you know, if you actually, let me do this. Yeah. So and so in mine, it's really hard to see because I made them really small. So actually, let me do this. 0.2D size. Oh. Right. And so like if you're like mine and you see these kind of green kind of circles around your cross section, those are actually clickable and draggable. So actually you can click those and drag them around in order to modify the cross section. But I think you might have to make them a little bigger. So let me make them 20. Okay. Right. And so if you go to one of these guys, it's a bit hard to see, but you can kind of see these little green you know, box circles, right?
Mm-hmm.
And so, you know, if you just did a machine learning one, you should have only two here. One in the middle where you can actually move it, and then one off to the side right here where you can change the size. But you can also modify, you know, each individual point around that. So I think what you have to do is that you have to, if you have a machine learning segmentation highlighted, if you click Spline Poly right here, then what that will do is that it'll create kind of these green boxes around the edges. Okay. And what you can do from here is you can just click and drag these edges and then, you know, pull them into your blood vessel just like that. Yeah.
Okay.
Yeah.
Thanks.
Yeah. So that's one way to do it. Yeah, so that might be a good option. So maybe you can use machine learning just to kind of get an initial circle down, and then change it to a spline poly here, so you can modify it to make sure it fits your vessel really well. Yeah, yeah. So really take your time with this. So you know, if you know, we'll come back to this on Tuesday. So, but in between, you know, now and Tuesday, if you want to go back and fix all your segmentations in here to make sure it hugs your vessel well, you know, that would be something good to do. Okay, so we have a couple more minutes in class. So is anyone else running into any issues for the tutorial so far?
Professor, when I made my model, it's like it doesn't like the textures are just like black and white and they flash like heavily when you move it around. It doesn't look like how yours looks.
I see. Yeah, I think that might be a rendering thing too. So that might be something with your graphics card. But send me screenshots and then I could take a look. And then you know, I can forward the thing to forward it to the dev team too, because you know, I think they should take a look, because it seems, it's like throughout today it seemed like there were some bugs that I want to report anyway to the dev team. So yeah, if you're getting, you know, weird, you know, flashing or, you know, weird textures on the surface, let me know, and then, you know, I'll forward that to the dev team. Yeah.
Is there a reason why your circles are green and mine are yellow? Is that like how good they came out or something?
I think mine are green right now because I'm in the segmentation view. But then if you go to the model view right here, then they show up as yellow. But if you're in the segmentation view, then you can modify them. So that's why they probably show up green. But from the model view like this, you can't modify the segmentations, and so that's probably why they show up different colors. Yeah.
Okay. Thank you.
Mm-hmm. Okay. So it's 6:45. So that concludes our class today. So you know, as I kind of predicted, you know, there were quite a few issues because it's you know, this is research software and it's you know, it's not designed, you know, really well because it's, you know, it's just designed by a bunch of grad students. And so we'll pick this up again on Tuesday just to kind of, you know, iron out all of the kinks and, you know, and to finish up the tutorial, because there's one more thing I wanted to show you guys with this. Okay. But thank you guys for tuning in today. You know, thank you for your patience. You know, hopefully, you know, it was at least, you know, some fun to look at some medical images. And so, you know, have a great weekend, everyone. And I'll see you guys on Tuesday. Great. Great. Thanks, guys. Yeah, that's going to be tough because it's because we don't have SimVascular installed onto the virtual computing labs. So let me think about it over the weekend, and then I'll let you know, because these workshops, you know, I'm not collecting anything for these workshops, but it is going to be used for your final project. But let me think about it over the weekend, and then I'll let you know next week.
Well, just to make sure the final project is individual, right?
It's individual, yes.
Okay, cool.
Mm-hmm. Yeah, I don't want you to upgrade your computer for this class, because it's, you know, it's that's going to be a lot of money, and so we'll find another option. So don't buy a new computer, don't upgrade yet. You know, let me think about it, and then I'll get back to you next week. Yeah. Yep. Thanks. Yeah. Have a good weekend. All right, Stephen, did you have any other questions? Okay. So if not, I'm going to close the call. So have a good weekend, and I'll see you next week.